Hey all of you, hope you guys are great. So finally we have completed all our smart contract. In this video we're going to work on our context management and we're going to write all the functionality which allow us to interact with our smart contract and which allow us to stake the token. Okay, so here I have opened the project and here you will find all the folder and file structure. So come back to this JS file folder. Inside that you will have all these files and this folder. So in this video we're going to work on our header JS file. There we're going to define all the global variable which we're going to use in our multiple file. So it's kind of state management we are doing here, okay? And that's what we're going to work in our header.js file. So let's start writing the code in our header.js file and define all the global variable. So we'll take a variable called network ID. By default, we are going with the polygon. The second one is going to be the selected contract. So we have 4 different contract and user can select any one of the contract. So that's the variable we have to take. Then we have to take the selected contract network name and that we have to define all the variables. So first we have to define the network name, which is going to be the polygon. So if you can pick any network like mainnet or Ethereum, Solana, you can take any network. Here we have to provide the explorer URL so they can click and they can go to there and they can verify. Then we can define the staking contract, and this one is staking. In that we have to define the 4 different contract so user can pick. So let's come here. We'll say this is the main network which I have defined. I'll simply write it down. Now we'll have the 7 days contract, and this name, the name I'm giving here, 7 days, 19 days, these are the most important one because on the base of this user will select the contract. Okay, so make sure to give the exact name, and this is the exact name we have to pass on the function. So just code along with me, everything will make sense. So we'll take an object, it will have the address, and we have to do for the other different staking period 10 days. Then we'll have the 30 days, 32 days. And with last one we'll have this 90 days. And these are the contract which I have already deployed on the polygon. So if you will get the final code, you will find that these are the contract which is deployed and which I'm using on. So that's why I'm using the same addresses here. But we're going to deploy the contract together, don't need to worry about that. So this is the entire staking one, and here we have to define the API. So all the contract will have the same API, because we have to redeploy the same contract with the different initialization. So later once we deploy the contract, we'll get the API, and that's the API we're going to paste inside this. So this is the staking one. Now we have to do for the token, same thing we have. So now we have to do the same thing for the token. So we'll take the token, we'll take the symbol, we'll take the address. You can have multiple token, but I will go with a single one. Then we'll have the API of the token. These are the global variable we have defined for our token and for our different contracts. Now let's take a couple of more variables. So let's take the countdown global, which we're going to use. So let's call it countdown global, and we'll use this variable to check the time period so we can display our countdown time. Now the second one will be the wallet connection. So we'll take this let web3, then we'll take the contract for the token. Then we'll take the contract call, and by default we're going to reload the 7 days contract. So whenever the user will come to our application, we're going to call this 7 days staking contract. But as a global variable, we're going to go with the 7 days. Now we can come here, we'll take this current address. Means once the user will connect, we're going to simply update that address to the global variable so we can use in our different application, in different places in our application. Then we'll take this web3, and we have to simply provide the RPC URL of a polygon, which we're going to use it to fetch the information. Now let's create the instant of the notified, and again we are using this particular library to display our error message. So let's configure that notify, and in that we have to send a couple of things. So duration, we have to send the position x right, y bottom, and again you can check their documentation, but I'm going to use it straight away. And that's pretty much. Hope this entire thing makes sense to all of you guys. This is the most important file because all the update of the state variable, we're going to do it here. And based on this data, we're going to call the contract and we'll allow the user to call the contract and reload the information. So this is the most important things which you have to keep in mind. So this is the entire staking contract and the token contract. This is the countdown and these are the state variables we have. In this common.js file, we're going to write all the functionality which allow us to communicate with providers. So we have to trigger MetaMask, we have to find out that which network we are connected with, and we have to look at for the event. So if users change his or her account, then we have to listen for that and we have to fetch the relevant information. So all the basic functionality we're going to write here in the common.js. So make sure to open this one and let's start working on it. So let's write the very first function. It's going to be an async function. And we'll say common provider. So what in this function we'll do, we'll try to fetch that what provider we are using. So right now we have multiple providers like MetaMask, we have a Web3 wallets and different type of wallets we have. So we have to fetch that which provider we are using to make the interaction with the blockchain. So in that we have to pass the provider, and first we have to build this if statement. So we'll say if provider is equal to the MetaMask. Okay, so I'll totally focus on the MetaMask, but you can definitely focus on other wallet, but I would recommend to go with the MetaMask, and after that you can do the modification. So we'll say if provider equal to the MetaMask, then we have to say if window.ethereum, because if we install the MetaMask, there is a Ethereum object in our window, because Ethereum wallet, the MetaMask wallet will inject this Ethereum object. So we'll say window.ethereum and window.ethereum.provider. So we'll have this particular data in that. And we'll take this variable called MetaMask provider equal to window.ethereum.provider, and we have to call this find method. In that we have to pass the provider. We'll say provider is MetaMask. Then we'll simply close it down. So that's a very simple function we are doing. We are simply connecting the provider and we are checking for that is that MetaMask is or not. Okay, all of this data you will find in this window Ethereum object. So that's the data I'm just simply taking here. So now I'll say if MetaMask provider window.ethereum provider equal to the MetaMask provider, then I'll take this return and I'm going to call this particular method. So this is the function which I'm going to call, and it's an internal function. We'll say common injected connections, and in that we have to pass the provider and we'll pass the provider. So MetaMask provider which we have taken, and this is the provider which we have got from the function. Okay, so that's what we have here. Now we'll say else if it's not there, then we have to say console.log MetaMask wallet not found, means the MetaMask wallet is not there, the user have not installed that one. So in such scenario we would recommend the user to install the MetaMask. So we can do that very easily. We'll come here and we'll say window.open, and we're going to provide this MetaMask extension location, so user can go there and they can download it. That's the simple logic. Come here. Now we have to simply return false, and then we have to simply close that one. Come here. We'll take else if window.ethereum, then return await, and we're going to call this common injected connections, and that we're going to pass window Ethereum and the provider. Else we have to console log out this particular one, MetaMask wallet not found. Then we'll take this try and catch block. We'll say window open, and we have to open that so the user can click on the button and we'll go to the there. So we have to check for the multiple conditions. First we have checked based on the MetaMask, and the second check we are doing based on the Ethereum object, and we'll call this focus. Then we'll catch an error if anything goes wrong into that. So first thing we have to say return false, and we have to simply close that one. So this is the very first function we have written which allow us to find out that which network we are connected, which wallet we are using. We are focusing totally on the MetaMask, but you can go with any other wallet. The process is exactly the same. So we're done with the very first function. Let's move to the next one, and this time we're going to build this particular function common injected connect. This is the internal function we have used in the provider, default provider, and in that we have to simply pass the provider and the provider name. Then come here, call this await provider.enable, Then we can come here, we'll say take this set web3 event, and in that we have to simply pass the provider. And again, this is the internal function we're going to create, so we are just using right now. Come here, we'll take this web3 and we'll say new web3 and we'll pass the provider. We'll say get connected chain ID from Ethereum node. So we have the entire object in our web3 model, and from there we are getting the chain ID. So let's take this, let current network ID, we'll say await web3.ethereum chain. This will give us the chain network ID, and then we'll say current network ID equal to the current network ID, and we have to convert into a string. Then we'll take this console log, so we can check in our terminal, sorry, in our browser console. Let's come here, let's look for the account. So we'll say window.ethereum.account, and this will give us the account, an array of account. So we'll take this one account, and we have to get the very first account. So we'll take it like it. Come here, we'll take this current address. We have this first account and we have to convert into a lowercase. So the address will have an uppercase or lowercase, and we are simply converting the very first account into a lowercase, and we are setting that to our global variable. So I hope you guys have watched the last video, the header part, in that we have defined a couple of global variables, and there we are updating it. So that's what we have. Let's say if current network ID is not equal to the network ID, in that context we have to throw our error message. So now we have to call our error component, and we have to simply pass the error message. So please connect wallet on network, and we'll pass the network name. So like it will automatically fetch the network which we are connected. So this one is the dynamic one. No matter in which network you deploy your contract, it will automatically fetch the name of that network, and it will display in the error message. Close this one. Now come here, we have to return this false. Just simply close this one. Come down, we have to take this contract, and now we have to take the variable we have defined for our token contract, and that's what we're going to use it here. So we'll say new web3.ether contract, and in that we have to simply pass the network, the ABI, and we have to pass the address of the token. And that way we can able to fetch the contract, the contract, okay, the token contract. So once we have the token contract, we can simply return this true, and that's the only thing we have to do here. So hope things are making sense to all of you guys. Whatever we have covered in these two functions, now we can simply come here, let's write the third function, and in that we're going to build this particular function, set web3 event. So this is the function we have used internally in the injected. In that we have to simply pass the provider, and here we have to build the logic. We'll say provider on change. So in this particular function we're going to listen for all the events. So when someone will change, when the user will change his account address in the MetaMask, we have to listen for the events, and when he log out or when he transfer any fund, we have to listen for all those things. So we'll pass this account chain, and we'll pass the account, then we'll call, so log out the account address. We'll say if account.length means, then we have to simply call this logout, else we can simply say current address equal to the first account. Simple. And we're going to take our contract. So this is the variable which I'm going to take, and we're going to simply call this get selected tab. This will give us the contract, and this particular function is reliable to let us know, let our application know that which contract we are interacting with. Okay, so we'll call this particular function, and we're going to simply close that one. Now come here, let's subscribe to chain ID. Okay, chain. Come here, we'll take the provider and we'll call this method on changed, and we'll pass the chain ID. Then we'll take the console logout, the chain ID, then we can log out simply from the application, because whenever the user will change, we have to log out the user. So that's the chain. Now we can take the another one, we'll call it subscribe to session connection. We'll take the provider, we'll call on connect. In that we have to simply console log out the connect, and we have to call this logout. So this is the third method we have. Now we can come here, we'll take the fourth one, we'll call subscribe to session disconnect. We'll take the provider on disconnect and we'll pass two argument, code and reason. Inside that we're going to take this console code and reason, and then we'll take this local storage and we're going to simply clear that one. We're going to remove everything from our local storage and we'll call this logout, and that's the web3 function we have is ready. Hope you guys are following that what I have covered so far, whatever I have explained, everything is making sense to all of you guys. Okay, we're just building basic functionality which allow us to interact with the MetaMask and look for the chain event which user is doing for changing the network or changing the ID, all of things. Okay, so let's come down and let's work on the other function. And this time we're going to call this particular logout, and in this it's a pretty simple function. All we have to do is we have to simply reload the browser. So this is the logout function we have used, and that's what we are building. Let's come here. Now we have to work on the add decimal, and this function is really very important for us to use in our project, because we have to just convert the user amount into ether. Okay, because you know that the transaction take place in terms of way, so we have to add 18 decimal points. So that's the function we have to write. So we'll call add decimal, and actually I found this particular function in the GitHub repository, but it was in the TypeScript, so I converted into a JavaScript. So in that we have to pass two arguments, num1 and n decimal. We'll take a variable called na_num, and we're going to simply split it out by comma dot. We'll say if anum1, if anum length greater than the decimal, then we have to simply pass this slice to 0 and the number of decimal. Okay, if it's not making any sense, if you are confused, just follow along with me. It's simple function which allow us to convert the ether into way. So that's what we are doing here. Just follow along with me. Then we're going to simply return this, and we're going to simply add all of this, and we're going to replace this with this. Come here. Now we have to return this anum0 plus 0, and we have to repeat end. So that's our add decimal function. Hope you guys have understood that what we have done. It's a simple JavaScript. All we are doing that we are identifying the number and we are splitting it by the comma. Then we are making some logic and doing some calculation and providing some methods on that based on the length. Pretty simple. Okay, so again, I don't go into deep. Just simply type this one, and this is the very common function you will find in most of the application which convert in like number into way and ethers. Okay, so this is the function we have, add decimal. Now come here. Now we have to create another function we'll call format ether error message. So in this we're going to build all the logic. So you can see that our notification pop-up shows the error which is occurring in our application. So here we're going to build the entire model, and we're going to pass this message to our notification bar, so user can know in the front end that this is the error happened in the function call. So let's do that. So in this particular function we're going to pass the error object. So we'll come here, we'll take this try and catch block, we'll take this variable and we'll say eForm error.message index of this, and we'll have this e2 and last index of. Then we'll take the var m1 error message index of token staking. Then we'll take the fourth variable em2 error message index of erc20. Then we'll take this var em4 error message index of internal JSON RPC error. So these are the variables we have taken. Now we can come here, we'll take this if error from is not equal to -1 and error2 is not equal to -1 error m1. So we have to set the same variable. If this is the condition, in that context we have to take this variable, we'll say error message stem, we have to convert into a JSON, we'll say parse, and we have to pass the message. We'll call this particular method which is there in the error object substar, and we'll pass our informations error from error2. Then we'll take a variable, we'll say message, and we have to simply build this particular if else statement to display different messages. And by the way, this all information is there in the error object when you will try to filter the data. I'm not going to getting into that details. That's a simple logic, simple JavaScript. Now we have to take if em not equal to this, then we have to return the token staking, the first index message, else will return the split ERC21. So you can see that we have two different contracts, one for the staking, and that staking contract has a multiple variation, like for 7 days, 30 days, whatever days you want to set. But we have two different contract for the token staking, and for the ERC20 token we have only one contract. You can add multiple the way we have done for the other staking contract, but I will go with the simple approach, and I want you to go with the simple approach. So this is the one logic we have. Now we have to simply say else return error message, and we can simply catch this error if anything goes wrong in between that. So we're going to simply log out that, and we're going to simply return this something went wrong, and simply close this one. So this is the entire error function we have, which allow us to find out that which error causing in which particular contract, whether it's a contract or whether it's a ERC20 token. So again, don't need to worry about that, because this is the general convention message which I found in the library, and again I have converted into JavaScript from TypeScript. So now we have to work on this particular function, get selected tab, because we have 4 different tabs for 4 different contracts. Okay, so we have to select that which tab, which contract user is interacting, whether he's interacting with the 7 days or 30 days or 90 days. So in that we will pass this S class, actually it's a object name, and we can come here, we'll say console dog the class, then we have to return the class, else we're going to go with the default contract, which is a 7 days. Okay, if user have not selected any tab, that means we'll go with the 7 days staking, but if he has selected any, and that's the variable we're going to set it, and that's the only thing we have to do here for this particular function, get selected tab. Now let's write the other function for get contract object, and this will give us the contract object based on the name. So we can come here, we can take this return new web3.contract, and in that we have to pass the ABI and the address. So we'll say select contract network ID staking ABI, and here we have to provide the dynamic address, and that way we can easily able to find that which contract we are interacting with. Everything will make sense, just follow along with me. And that's the function we have done with get contract object. Now looks pretty good, and this is the entire function we have written. It's a pretty huge one. You can see we have so many things as going on, but if you look at, these are the very simple JavaScript we have written for fetching the information, for building the connection. So this is the very first function we have, common provider director. This will trigger to find out that which provider we are using in our application. Simply close this one, and that's the one we have. Now we have this common injected provider. In this we're going to calling in this we're going to simply pass this variable, and we're going to simply make the connection with the blockchain, and that's what you can see here. That's what we are doing here. We are looking for all the events which is taking place in the chain. Now we have this set web3 event. So simply we are setting up the account, and we are finding the contract which the user is trying to interact at the initial, when the application will reload. So that's the one we have. This is the logout function. You can see these are the multiple functions we have included into this chain, connect, disconnect. So these are the functions we have included. This is the logout one, and this one is the decimal one. So close this one, and here we have the format ether message here, and here we have the get selected tab. By default we are going with the 7 days, but if user can select any contract, and that's the logic we have built here. Simply close this one, and this is the function for getting the contract object, and this will be the setup. So all we have to do is to call this get contract object function into our smart contract function, and we'll have the object of the contract, that which contract is user is interacting with. So it's a kind of context management we are doing. So in React we have a state management, just like that we have here in the context management we are doing. So this is the entire function we have written in the common.js. Hope you guys have found everything clear here. Now we can move to the next one. So click here. Now we can simply go back to the other function All of you, hope you guys are great and you guys are enjoying this project. In the last video, we have completed our common JS functionality. So we have built all the functionality which allow us to communicate with our providers, the blockchains, and listening for different events. We have written some important function for managing the errors. So if you guys haven't watched that video, I'll link in the I button or in the description so you guys can watch that. In this video, we're going to start working on our smart contract functionality. So we have written the smart contract. Now is the time to build the function which allows us to interact with the front end and where we can call the smart contract. Here we are in the index file, and by default we're going to call two functions. The first function will reload the entire information, entire data about the smart contract, and it will display in the front end, and we're going to call the MetaMask. So the MetaMask pop-up will pop up so the user can connect their wallet. So let's call this function call, and first function we're going to build is this one, load initial data. In that we have to simply pass the contract. So we have different contracts, so what contract data you want to load. So I will go with the 7 days contract, but this one is dynamic, user can select and they can change it. So I'll pass the name which is the 7 days, and this is how we're going to load the data. So all we have to do is to change this particular string. So it is 7 days, means 7 days contract we are looking for. If we go to the 90 days, we'll pass this 90 days. If we go to the any other contract name, so that's the name we're going to simply update and it will give us the information. Let's call the second function, we'll call it connect me, and in that we're going to simply pass this particular provider and it will trigger the MetaMask. Now we can simply call him here, we'll call this connect wallet, and we're going to create one function which allow the user to connect based on the click event of the button, but that one is totally optional. I'll go with a simple approach. Now we can come here, we'll create the very first function called open tab, and in that we have to pass this event and name, and here we have to simply update that which contract user try to interact with. So we'll take this console.log and we have to look for the name which you can easily able to find in the terminal, which we're going to look at. Now I'm going to simply take this particular contract call because this is our global variable which we have defined in our header file, and we have to simply update the contract name the user try to interact with. Then we'll take this get selected tab, and in that we have to simply pass the name. So this will also update our global variable of the user interaction and the selected tab. And we'll simply call this particular function load initial data. So this function is absolutely ready. We're going to pass. So in this function, what we are doing, we are updating our global state and we are updating our initial load data function, which will give us the relevant data of the contract. So this is the very first function. Now we have to write the second function, and this one is going to be a quite big one. So we'll call this async function and we'll say load initial data, and that we have to pass this S class, and this is the name of the contract. And first thing we have to console log out this S class. Then we can simply take this try and catch block because we have to catch an error if anything goes wrong. Then we'll take this clear interval because we are displaying our counter time on, and I want to remove that one. So that's what we have to clear here. We'll pass this countdown global because this is the global variable we have here, and we have to simply pass the global variable. Now we can come here, we can take this let contract object and we can get that very easily. We have to simply call this new web3 main and we have to pass the relevant information about the contract. So this is the dynamic contract we're going to use it. So we'll say selected contract chain ID staking, and we have to have the API because all the contract will have the same API. The only changes we have to do in the address of the contract. Now we have to get the address. We'll say selected contract network and we'll take the staking, but here we have to provide the class and we'll say address. So in that way we'll have the address of the contract which user try to interact with. Now we can come here. So we got the contract object. Now we can build and we can simply fetch all the information from the contract. So we'll take this ID element. So we're going to target all the element based on the ID. So we'll say let total user await contract object, and we have to call the function get total user. It will give us the data. Now we have to simply take the data of the percentage, which we can get app, and we're going to simply call it. Then we have to get the user. We'll say let user detail await. We'll say get user. We have to pass the current address. we can come here, we'll take this const user, and here we have to simply update all the information. So we'll take this last reward calculation time, and the data is available here in the user detail. In that way, we have to simply update all the time. So we'll say user details stake time, reward amount, user detail reward amount. We have reward claimed so far, user detail reward claimed so far. Now we have this stake amount, user detail stake amount. We'll come here, we'll take the address, and we have the address of the user. So we can simply take this in this particular object, and now we have to store this one. So we'll take this local storage, and we're going to simply store in the local storage so we can display in the front end part. You can use the backend API, but I'm not going to use that one because again it's going to be a decentralized centralized. I just want to make it 100% decentralized. So all the information we're going to store about the user in their local system. So let's store there. Now we can come here, we'll say let user detail balance, let user detail balance, user detail stake amount, and we have to convert it into a way. Now we'll take this document.get element by ID. So this is the ID we have to assign in our HTML. So let's target that. We'll say total locked user token, and we have to simply update the information, the amount. Okay, so make sure to give the exact ID name which I'm giving here, because this is the exact ID we're going to give in our HTML, so the data will display in the front end. So that's the first thing we have targeted. Now let's take the element ID. Now we'll document.get element by ID, and the ID we have to target is number of stakers value, and we have to simply update in our HTML. Now we have to get the document.get element by ID, and we have to get the percentage app value feature, and we have to simply update that one. So we have updated all this in the HTML. Now let me give this comment. Now we have to target the element based on the classes. So we'll say let total locked token, and we have to call our contract to find out. So we'll call this particular function get total stake token. Then once we have the data, we have to call this particular one unstaking fee, which we can get from the contract. Let's call the function early unstake fee percentage and call. So this will give us. Now let's come here, let's target the element. So we'll say document.get element by ID. We'll call total locked token value, and we have to simply update the data in the element. We'll say total locked token, and we have to convert it into Ether, and we have to it will display the token name. So we can come here. Now we have to get this document.query selector all, and we have to get this one unstake fee value. We'll take this for each because we have 4 different components, and we have to display the same value in 4 different components. That's why we have taken this query selector all. And that we're going to take this function, we'll say element, and then we have to simply update the inner HTML data with the data. And here we are going with the percentage, and here we are going with the percentage. So that's what we have here, and simply updating. Now we'll target the let minimum staking. So let's get that from the contract, minimum staking amount, and call the function. Let's call the convert it into a number. Then we can simply take this. This one is going to be a dynamic one. So if user has the token, then we can display the balance. Otherwise, we allow them to go to the specific place and they can buy the token. So if you have a pre-sales token page, so we can redirect them to there and they can buy it. So let's build that logic. So we'll say if minimum staking, then we'll say minimum A, the amount, and we have to simply convert it to the string. So we can display that, and we'll display the token symbol, means he has something. Else we can allow the user none, or you can display a particular message where a user can go and buy. But for the time being, let's go like this. Then we can come here, we'll take this document dot query selector all, and we have to target the element, and we have to simply update that. So we'll run a for each because we have to display in 4 different components. So we'll say a function, we'll take the element, and we're going to simply target the inner HTML, and we have to simply update the data. So that's it. Then we have to target the document dot query selector all. We'll take the max one, so we have to do the exact thing for the max, and we're going to simply say delimit inner HTML, and we have to simply provide this hardcore data, or you can take this data from the contract, but just keep it for timing because this is the data, this is the exact amount I allow user to store in the contract. So we are going with this, and we can display the token symbol. Close this one. Now we can close this one. Come here, we'll take this variable is taking pause. So now we have to focus on the status, so whether the contract is allowing user to stake token or not. So that's the status we have to display in the front end. So we'll say is taking pause. We have to call the contract function. We'll say staking status. This will give us the data. We'll say let staking status pause text. So we have to display different status. Okay, so we'll say let start date await, and we have to get that, which is really very easy. Now we can come here, we'll say start date, we have to convert it into a number, and we have to simply multiply with this 1000, so we can convert it into a second. Now we can take this end date, and we have to do exactly the same thing. So let's call the function. Once we have the end date, now we have to simply convert into a number, and we have to multiply with 1000. So we have start days, we have end date, and here we're going to build the logic. So we'll say take a variable called let stake days. So what days they are interacting with. Okay, so stake days. So now we have to get the stake days of the contract. So we have to call the contract called stake date, and we'll take a variable called let day, and we have to simply use the math, and we have to simply convert it into a timestamp. Then we'll take this let display date. Inside that we'll take this day is greater than 0. Then we have to display day plus, if its days is equal to 1, then we have to display days as days. That's a simple JavaScript. Now let's come here, we'll take the document dot query selector all. We have to target that, and we have to simply update the text. We'll say display date. So this will display our time. Close that one. Now come here, we'll take a variable called reward balance. So how much balance is rewarded so far after staking certain token. We have to call the contract function. We'll say get user estimated reward, call the function, and in that we have to pass the address of the user. We have to take the element, and we have to simply display the balance of the user. We'll pass that. Okay, so we are converting into ether. So that looks pretty good, and we have to display the token name. Now we'll take this user token balance. So let's write that function for that. So we'll take this balance main user, we'll take the current address. And the reason why I'm building this particular logic, because sometime what happened that maybe the user is not connected with the MetaMask, so we don't have his address. So on the base of that, we don't want to have any error in our application. So that's why we are making this dynamic one. So if user has address, then it's going to be called this particular function, otherwise it's going to be skip. Okay, so we'll say if there is a account address exists, means user is connected, then we have to simply call this function, the contract token function, and we have to call the balance of, and we have to pass the address of the user. So in that way we'll have the balance, otherwise we don't need to call anything. So simple logic. Come here, we have to take the balance, and we have to convert into a number, and then we have to simply update into our HTML. We'll target the document get element by ID, and we have to simply target the element, and we have to simply update the inner HTML with the user balance. Simple function. Hope whatever I have covered so far, everything's making sense. And then come here, take a variable called current date, and we're going to use this JavaScript method new date, and we have to pass this particular function get time, because we have to get that one. We can come here, We'll take this one. If is staking paused, means the staking is paused, then we'll say is staking pause equal to pause. Else if current time is less than the staking date, then we'll say is staking text equal to locked, because we have to check for multiple time period, for pause, for lock, for duration. On the base of that, we have to display the status of the contract. So we'll say else if current date greater than the end date, means is staking is ended. And the last one is going to be the is staking is none of these, then means it's active. So this is the if else statement, and we are simply updating the data. Now we have to call the DOM element, and we have to simply update the text. So we'll say get selected all, we have to target the active stated staking, and we have to update the data. So we'll take this element, we'll call the element in our HTML, and we have to simply update the data in our HTML. That's it. Pretty simple. Okay, I hope you guys are familiar with JavaScript. So that's why I'm going a little faster, because these are the basic JavaScript we are doing here. Come here, we'll say if current date greater than the start date and current date is less than the end date, then we'll say const element, we'll say document.get element by ID, and we have to get the countdown timer, because we have to display the timer. And we'll take the variable, we'll take this get generate countdown, and this is the function we're going to create, and in that we have to pass the two things, element and the end date. Then we can take this document.get element by ID, and we have to get the countdown title value. Once we have the value, now we have to simply update that into the front end. So we'll say staking ends. Close this one. Come here, we'll say if current date less than the start date, that means get element by ID, and we will say that countdown title value, we'll say generate countdown time, and we have to pass the element and the end date. Multiple conditions. Now we're going to take this document get element by ID, and we have to simply update the data. So we'll say title in our HTML is going to be the staking started in. Okay, different stated for the countdown, one for end and the other one for is starting. Now we can come here, we'll take this document dot query selector all, and we have to target this app value, and we have to run a for each to update all the elements. So we'll take the element dot inner HTML, and we're going to simply call this particular percentage value. Looks pretty good. Come down here. Now we have to write the catch block if anything goes wrong. So we'll say error. First thing we have to do is console log of the error. Second thing is we're going to call our error component, notify error, and we'll display the message. So we'll say unable to fetch data from the network name, please refresh this page. So this is the first error message. Close this one, and that's the entire function we have written for reload initial data. So whatever we have done so far, I hope everything is making sense to all of you guys. These are the very simple function we have written. It's allow us to fetch the information from the contract, and we are simply feeding those data in our HTML. So that's the first function. Let's move on. Now we're going to write the second function called generate countdown. Okay, so let's build the logic for this one. We have to receive two data, element and the claim date. Then we'll say clear interval, in that we have to pass the global countdown logo, countdown global, and we have to clear that one. Now we have to set counting down. We'll take a variable countdown date, and we'll call this new date. In that we have to pass the claim date, and it will give us the time. So again, these are the JavaScript method which I'm using here. Once we have the countdown date, then we can build this one and update. We'll say update countdown every 1 second, So we'll take this countdown global and we're going to simply call this set interval, and we'll pass a function because set interval will take a callback function. And inside that, we're going to simply take the today, date and time. We'll take a variable called now and we'll call this particular method. This will give us the current date and time. It's a huge string. So once we have the date, we'll take this find distance between now and the actual time, which is in the future. Okay, because we are allowing user to stake the token for a particular period. Okay, so obviously it's going to be in the future. So now we have to find the distance between them. So we'll take this variable called distance countdown date minus now, and this will give us a distance. So once we have the distance, we'll call this time calculation for days, hours, minutes and seconds. Then we'll take a var, we'll say days. We have to use this math property and we have to pass the distance multiply by 1000, and we have to just convert this entire thing into days. We'll take this hour, this one is the day and this one is the hour. So let's do the same thing, provide all this and we have to multiply by 100, and then we have to simply provide this 60. So this is the hour. Now we have to do for the minutes, take the math distance, convert it, then we have to do 60, then we have to take the second, math floor distance 60 and this. So this will give us the second. Looks pretty good. So we have all the information, like we have days, hour, minute and second, and now we can feed this data into our component. So we'll say display the result in the element. Now we can say element inner HTML and we have to simply pass the data. So we'll say days plus days, hours, minutes and second. So we are simply updating in our HTML. Right now we can see that we are taking this particular element dynamically into this particular function, or you can go with the hard code one, both will work fine, but I would like to make things more dynamic. Okay, and this is the another way which you can add to update the data, but this one has a different element. So that's the display one. Now let's write the another function. We'll say finish, write some text. So once the time period is over, we have to display certain text. So let's do that. We'll say if distance is less than 0, then we have to simply update the text. So we'll clear this particular interval, the global countdown, and then we have to simply pass this particular message. Refresh page means the time is over, and close this function, and we have to call this particular function every single second. So that's why we have given this 1000, and that's it. So this is the entire function for our countdown. Hope everything's making sense to all of you guys, and you guys have understood that what we have done and much logic we have tried to implement here. So let's move ahead further. These are the basic function we have written. Now let's write the another function which is going to be async function, and this function will call connect me, and this will allow us to connect from the MetaMask. So in that we have to pass the provider, the name, and we'll say take this try and catch. We'll say let common response, we'll call this await common provider director, and we have to simply pass the provider. So this is the function we are using, which we have defined in our common JS file. So we are simply passing that provider in the folder, and it's going to set the entire variable. So once we have that variable, then we have to simply console log out, and we can say if common response is not there, then we can take this console.log please connect, means the user is not connected, and else let the contract which we want to interact with, in that we have to simply call this get selected tab, and by default we are calling this 7 days contract. Okay, so that's why we don't need to pass any data into this, and we have to simply console log out the entire contract object. And now we have to catch an error if anything goes wrong. We have to pass that into our notification, the error message, and that's the connect me function for the MetaMask. So far things are clear. Let's move ahead. Now we have to write an async function, and this function will call stake token. So this one is the actual function we are writing for interacting with our smart contract. So whatever we have done, These are the basic functionality we have written, and now we're going to write the staking contract function. So we generally going to have two approaches to write the staking token functionality. One, you can write the entire function in the same function, but it's going to be a little bigger, so it's always better that you have to make two separate function. One function is going to be the internal function, and the one function is we going to use it for calling in the front end. Things will make sense, just follow along with me. So this is the name of the function we have given. Now let's build the logic. So we can come here, we'll take this try and catch block, because if anything goes wrong we have to catch that. We'll say let token, okay, so the amount of token which user wants to stake, so we have to get that value. So we can get it very easily. We'll say document dot get element by id, and we'll have this particular element, the input field will have this id, and from there we can get the value. So we have the token value. Now we have to take this if, means we have to throw an error message if the user called the function without providing any token amount. So we have to throw the error message. So we'll say return this. You can return error message as well. Now come here. So now we have to check that the token which user have provided is a number or not. That's the first check. Then we have to check that if it is equal to 0, and the third check we have to do is that we have to check that if that is less than 0. So these are the three check we have to do, and we have to simply console logout invalid token amount, and we have to return. So far so good. Let's move ahead. Now we can take this token and we have to convert it into a number, so we can pass into our functions, because we can pass as it is string because we have defined number in our contract. So we can take this let token to transfer. We'll take this decimal function because we have to convert that into a way. So we'll say add decimal, we'll pass the token and the 18 decimal points. It could be 16, it could be 8, it's totally up to you that what token you want to use it, because this function we have built add decimal, it will work fine for all the different tokens. So we'll have the token to transfer value in way. Now we can pass it. So we can come here, we'll take this console.log token transfer, and this is the amount we want to transfer. We'll take a variable called balance user. We'll take the balance main user, and we'll have to take await contract token, and we have to simply check for the balance of the user, whether he or she has the balance or not, which amount he want to stake. So that's the check we have to do. So once we check that he has that balance, then we can simply take the balance of the user and we have to convert it into a number, and we have to convert this into a way. Then we can console log out in the console. So that's pretty simple. Now we can come here. Now we're going to take this if statements. We'll say if balance main user is less than the number of token, then we have to throw this error message, and we're going to display that you can come to this place and you can buy that one. So let's throw that error message. We'll say that insufficient token on, we can define the network name, please buy some token, or you can provide any link so they can go there and they can buy that one. But just try to keep it like it for a time being. Okay, so now we can come here, we have to return this one and close this if statement. Let's take a variable called class, and we have to get the contract. So we'll say get selected tab, and in that we have to pass this particular variable contract call, and this one is the global variable we have defined our header. So by default this is what we're going to do it, and in this we have to pass the contract name which user try to interact with. So in that way we'll have the entire object. Now we can simply console log out and we can check in the terminal, which we're going to do it. Now we can take a variable called balance main allowance. We'll call the contract token contract, and we have to call this method allowance, and in that we have to pass the current address, and we have to pass the address of the token, address of the contract, staking contract, because the staking contract has the permission to make the staking and make things works. So we have to allow the staking contract. Now we have to call the function. So let's come here, we'll say if number means the main balance allowance is less than the token transfer token transfer, we can call this approved token spend, and in that we have to pass the transfer amount and we have to pass the contract which user try to interact. If the token is not approved, if the main allowance balance is less than the token transfer, else we have to simply call the stake function. We'll call say stake token main function, and in that we have to pass the token transfer and the class, the contract. And that's the very simple logic we have built in this if else statement. What we have done, that first we are checking for the allowance balance, that how much allowance the staking contract has. If he has less than the transfer token, then we have to first call this approve token spend and first approve the token and then stake. But if he has the enough approval, then we can simply call the stake token function, and that's what we have done. Now let's go ahead and we have to simply close this function. We'll call the notified dismiss, and we're going to simply call the error message. And by the way, if you want to learn more about this notified error, make sure to check the library. They have explained every single thing, that how you can use their library to display the error. I'm just using all the method they have. So this is the stake function we have, and now we have to build the internal function. So let's come here, we'll take a async function, and first we have to work on the approved token. So we'll say approved token spend. We have to take the minimum, the amount, it's coming in the term of way, and we have the contract. Let's take a, now we have to estimate the gas amount, because here we are using our native token for making the staking process, not any native change token. So we have to calculate the gas amount for that. So let's take a global variable. We'll say let estimate, and we can calculate that. That's a very easy. We have to take a try and catch gas estimation, and we'll say await contract token contract, and in that we have a function. So we'll say approve, and that we have to simply pass the two information. So we have to pass the address, and we have to pass the amount. So this will give us the estimation, and on that we have to call this particular function guess estimated gas, and we have to define the address, which address of the user who will pay for the gas. So we'll say from current address. Okay, so what I'm doing here, we are trying to estimate the gas code for making this transaction. We are passing these two variable in our approve function, and we are calling this particular method get estimate gas, and we are defining the address who will pay the gas amount. So in this way we'll have the estimation of the gas, that how much it's going to cost for making this transaction. So this is the estimation we got for the gas. If anything goes wrong, we have to throw the error message. We'll say notify, and we'll have the error message, and we'll simply return that one. So this is for the estimation, and now we have to call actual function. So let's call that one. So we'll say on contract token, because token we have to transfer into the contract. So we'll say method, and we have to call this particular function approve. We have to pass the same data, we have to pass the address of the contract, and we have to pass the amount, and we have to simply define the gas amount from, and we have to define the estimated gas. And on this we can call multiple functions. So we'll call this on change, and we can simply log out the hash of the transaction hash, so you can check. So that's the on chain. Now let's cut one more time, and this time we'll say receipt, and we can simply console log out the receipt. We'll take this stake token main function, we're going to simply call it. Again, this is the function we're going to build in a while. So first it will approve, then it's going to trigger this one, and everything will make sense. And then we have to pass the amount for transfer, because the staking is already done. Now we can simply catch error if anything goes wrong. Console log out, and we have to throw the error message, return, and close this one. So this is the approve function for our token. Now we have to work on the stake token main. which will actually stake our token into our staking contract. So first we have a proof, then we have to stake. Let's work on the function. We'll say function stake main token, and that we're going to receive the amount and the class. So we'll take this let gas estimation. We have to calculate the gas amount. So let's get the contract. So we'll say contract staking, and we have to call this function get contract object, and all we have to do is to pass the name, and it will give us the object of the contract. Once we have the contract, we can take this try and catch block, and we have to estimate the gas cost. So we'll call this staking contract, and we'll have to pass the staking amount because that's what it need in our smart contract. And we have to call this gas estimation, and that we have to pass the account, and we have to close this one. So in that way we'll have our gas estimation, and now we have to simply catch error if anything goes wrong. Now we can call our notification, and we can display our error message into that, return that one. So that's the one. And now we have to actually interact with our staking contract. So let's call the contract, and in that we have to call the stake function. We have to pass the amount, we have to provide this send method, and we have to pass the user, and we have to pass the gas estimation, and we have to look for a chain event. So we'll say on recipient. So in this we'll have the entire data. Now we're going to store a couple of data into a local storage. So we'll come here, we'll console log out the entire recipient. Now we'll take a variable called recipient object, and in that we can build the entire object which we're going to store in our local storage in form of array. So we can fetch that, and we can display into the front end. So let's come here, we'll have this token, we'll take the amount, then we'll take the from, then we'll take the to, then we'll take the block hash which is available in recipient block hash, then we'll take this block number, then we'll take the accumulative gas used, then we'll take the effective gas price, then we'll take the gas used. You can store as many data as you want. There is tons of data available in the recipient, but we're going to receive this data and we're going to store in our local storage. So let's go ahead, let's take the status, and we can take the transaction hash, and we can take the type, and that's the entire object for the recipient object. Now we have to take this data, we'll take an array because the user can stake the token multiple times. So we cannot go with the one data, we have to display arrays of data. So we'll say transaction, we'll take a transaction history, an empty array, and all we have to do is we have to take a variable called const all user transaction, and we'll call this local storage. First we have to get that data, because when the user will call this function, first we have to get and then we have to push. So we'll call this particular variable local storage get item transaction. Now we'll say if all user transaction, we'll call this transaction history equal to the JSON parse. We'll say local storage get item, and we have to pass the transaction history. Then we'll take this transaction history and we have to push that object. Then we'll take this local storage dot set item, and we have to give the transaction, and we have to simply push the data, the transaction history, and looks pretty good. So this is what we are doing. First we are getting, then we are pushing, and else we can simply display the transaction history and the recipient object, and we'll set this to the local storage transaction, and we have our transaction history. Okay, close this one, and that's the only thing we have to do here for setting the data after a successful stake. Now we'll take this console and we'll simply console log out all the transactions so you can see and we have to simply redirect the user to the analytical page. So let's build the URL analytical and close this one, and we have to look for the on change, and we can simply log the hash of the transaction, so we can see that whether our transaction is successful or not. And come here, we can call error if anything goes wrong, console log of the error, and we have to display the error notification, the error message, and return this. Close this one and close this one. So this is the entire function for stake. Hope things are making sense to all of you, that what logic we are following. Okay, let's move ahead. Now we will take a function. This time we're going to call unstake token. So we have written for the approval, we have written for the stake. Now we have to write a function for withdrawal of the token. Okay, if user decides to withdraw the fund from the contract, they can do that. So let's build that functionality. So we'll say unstake token. We'll take this try and catch block. We'll say we have to get the token, that how much he or she wants to withdraw from the front end. Once we have that, we have to do the couple of check. We'll take this if it's there, otherwise we have to simply return it. Then we can come here, and then we have to check for the number, multiple condition. It's a number, or its value is equal to 0, or its value is less than 0. Then we have to display our notification mirror message, invalid token error message, and then we have to notification error message, and then we have to return. So this is the if statement we have. Now we'll take the number token, and we have to convert into a number, and we have to use the same logic which we have done above. So we're going to simply call this decimal, and we have to convert it. Then we'll take this the contract, which contract user trying to interact with. We'll call this get selected tab, and we'll pass the global contract, so global variable. Then we can take this let contract staking, and we have to get the contract object. We have that. Once we have that, we have to fetch the balance of the user, and we're going to simply call this method get user address, and then we have to call so once we have the entire information about the user, we can simply get the balance of the user. That's how we can get it, and we have to convert it. Once we have the balance of the user, now we'll check for a condition. We'll say balance user is less than the token amount, obviously. If this statement is false, then we have to throw this error message. We'll say insufficient stake token, and we have to give the network name. So that's the if statement we have, and we have to simply return it. Let's come here, but if he has the token, then we'll go on, and we're going to call this particular function unstake token main. So this is the internal function we're going to create, and in that we have to pass the token amount and the contract and the class, and we have to simply catch error if anything goes wrong, and display the error message. We have to dismiss first, and then we can display the error message, and close that one, close this one. So this is the unstake token function we have, and now we have to build this particular function unstake token main, where we're going to build all the logic. So let's go ahead. We'll take a async function unstake token main. In that we have to receive the amount, we have to receive the contract, and we have to receive the class. Then we'll take a variable called gas estimation, because we have to calculate that how much gas fee we're going to pay for this transaction. We'll take a try and catch block gas. We're going to simply call the function. So this is the function we're going to call in the contract unstake, and then we have to pass the amount. Then we have to call this estimation gas. We pass the user address, and it will give us the estimation gas amount. We have to close this one, and we have to catch an error if anything goes wrong into that. Looks fine, and we have to display our notification error message. Now we have to interact with the contract and make this entire unstaking and transfer the token from the contract to the user. So we'll call the contract, call the method, and we have to call this unstake, and that we have to pass the amount. Then we have to set the gas estimation. So we'll check the user, and then we have to set the gas estimation, close that one, and here we're going to get the recipient. And again, this data we're going to store into the local storage, because this is the recipient data we have, where we have all the data. So let's take a variable called recipient object, and we're going to push this particular data into the array we have in the local storage. So let's build that cut quickly. So we'll take the token amount, we'll take the from, we'll take the to, and we'll take the balance block hash, we'll take the block number, we'll take the cumulative gas used, and we'll take the effective gas price, we'll take the gas use, we'll take the gas status, and we'll take the transaction hash, and we'll take the type. Simply close this one. So this is the entire recipient object, and now we have to do the same thing. So let's do it very quickly. First we have to get the transaction history, then we'll say all transaction we have to get from the local storage. Once we has from the local storage, we'll have to check for the if else state condition. We'll say that if there is a all user transaction, in that context we have to simply take those data, we have to get all the data from the local storage, and then we have to take the history, and then we have to simply push that into the transaction object, and then we have to set that to our local storage. Okay, we have set that local storage. Else we'll say transaction history, and we're going to simply push this object into our local storage straight away. We'll take the local storage set item, and we'll give the name transaction history, and we have to set our transaction history. Simple. Hope you guys can understand that what we are doing here. So if there is a data in our local storage with this transaction history, so then we are fetching those data and then we are updating. But if we don't have that one, we are straight away updating that. So that's the logic. Looks pretty good. Close this one. Now we have to take this window and we have to simply reload the browser, or we can redirect to the user to the activity page. And let's close that one. And we can look for the transaction hash. So simply log out that data to the console so the user can check that. And we have to catch an error if anything goes wrong. So looks pretty good. And we can simply console log out. We can simply throw the error message, and at the end we have to return. So this is the unstaking, and now we have to build the internal function. So we'll say function claim token, and this function will allow user to claim the reward which they have earned after staking the token. So let's write that function. So we can take this try and catch. We'll take this contract. Once we have that one, we have to simply pass that to the contract object, and it will give us the entire contract object. So we got the name, then we are passing that name to the get contract object, and it will return the entire object of the contract. And now we can make the connection. We'll take this variable called reward balance, and we have to get the balance of the user from the contract. So get user estimated reward function we have, and that's we have to simply pass the address, and it will give us the balance of the user. So we'll have the reward balance, we have to convert it into a number. Once we convert that into a number, we can simply console log out. After that, we'll take this if reward balance means there is not enough balance, there is no reward, and that we can display the error message that there is no error, and we can display our insufficient reward token to claim, and we can simply return that one. But else he has something, then we can simply allow him to claim the reward, and we can simply pass the in this function claim token main, which we're going to create, and again it's an internal function. So in that we have to pass the contract and the class, and we have to catch if anything goes wrong. Let's console log out the error, and we can use the dismiss notification, and we can display the error message in our notification bar. Close this one. So this is the claim reward. Okay, we are done with this function. Let's come down, and now we have to create this internal function, claim token main. So let's call a async function, and we have to give the name, and we have to receive the contract, and we have to receive the name. Then we can come here, we'll say we have to estimate the gas cost. Then we'll take this try and catch. We have to follow the same pattern. So estimation gas, we're going to take the contract, we're going to call the function claim reward, and we have to pass the account, and we have to catch, console log out the gas, and we have to catch the error if anything goes wrong. So once we have the gas cost, and return that one. So once we have the gas cost, now we can simply call the function. So come here, we have to call the contract method. Now we can call the function. So let's call the claim reward, call the send. We have to pass the user address and the gas cost, and we have to call this on change recipient, and in that we'll have all the data once the transaction will go successfully. So we'll console log out the entire recipients, and now we're going to simply set the object. Okay, so we'll take this recipient object, and now we have to simply update the data into our local storage. So let's quickly take that one. The same thing we have to do here. Let me type it very quickly. So the entire object is ready. Now we can come here, we'll take a variable called transaction, an array, and the same thing we have to do. So we'll take this all user transaction. We have to get the data from the local storage first. We have to check for the length. If it's there, then we have to simply convert that into the local JSON, get that all, and then we have to simply push into an array, and then we have to simply set into our local storage. Simply set that, close this one. But if we don't have anything, then we can simply straight away push that into our local storage and set that. So local storage, set items, transaction, and we can pass the transaction history in stringify, and that's pretty cool. Once everything's done successfully, we have to redirect the user to the activity page, the profile page, and there you can find all the data. And now we can simply console log out the transaction hash, and that's the only thing we have to do here. So we have to catch an error if anything goes wrong, console log out the error, then we can simply pass the error message to the notification component, and it will pop up in our front end. And that's the entire function we have written to this huge index file. Some of the functions are quite repetitive in nature, but I believe that you guys have got an idea that how you can build this entire logic and what we are doing exactly here. So we are fetching the information from the contract and we are passing into the component. First, for making the transaction with the smart contract, first we need the gas estimations, gas cost, and then we are calling this method. If you don't do that, if you call the method straight away, you're going to have an error because your contract will ask for a gas estimation and you will get that error. So it's always better that you have to calculate the gas cost which you go to pay for the transaction. So things looks pretty good. So we have this tree function, then we have this open tab which update the context, then we have our loading data function, then we have the counter, then we have the connect me, then we have the stake token, approve token spend, main, unstake token main, claim, and claim token main. So this is the function we have written. It's pretty huge, and now we are done with that. So we are done with this common JS, we are done with this header, we are done with this index. So in the entire thing is pretty awesome. And now what we're going to do is, and this is, we don't need this one, initial one, just leave that one. So we have done with this common JS, we have done with this header, and we have done with this index. So we have done with all the three important files which allow us to connect with our smart contract, and that looks pretty good. I'll close this one, and now we're going to start working. And this is the data folder we have. So right now we're not going to work on it. First we'll work on the staking file. We're going to build all the logics and connect to the front end. After that we're going to work on the other pages. So now we're going to start working on the staking page. So this is what we're going to work next. So let's move to that.